Okay, so if you look on the board, we have an equation, and it is a radical equation because it contains a radical sign, a square root. And the rule to solve a radical equation is real simple. The first thing you do is isolate the root symbol. So if you look on the left side, none of these terms can be moved because they're stuck inside the symbol, like they're stuck in the house on fire. Okay? So we can't move any terms. So then to get rid of a square root, we do the inverse operation, which is square. And if we square the left side, we square the right side. We know squares and square roots because they're inverse operations. Please excuse. They cancel out, and that would leave us here with 4x squared plus 3x plus 2. On the right side, there is no square root. So this is not going to cancel out this square. We have to perform this operation. We have to do 2x times 2x. Well, 2x is a monomial, and a monomial times a monomial, we don't use FOIL. We just multiply this in our head. So 2x times 2x is 4x squared. What you'll notice is you still have an equation, but there's no longer a root symbol. So this is not a radical equation. So what happens here is in algebra, anytime you have an equation and you take out a symbol, now you've got to reevaluate. Is this a good old Algebra 1 linear equation, or is this a quadratic equation? Well, I see the x squared, so it's quadratic. First rule of thumb is we try to set our quadratic equations equal to 0 to see if we can factor. So I'm going to set this equal to 0. I'm going to move my 4x squared by subtracting. I'm going to move my 4x squared. What happens here is 4x squared minus 4x squared are going to cancel out. They're additive inverses. There are no x squareds here, so that's gone. So that leaves us with 3x plus 2. And on the right side, again, 4x squared minus 4x squared is 0x squared. Well, I have to put something on the right side, so I put 0. I don't write 0x squared, because 0 times anything is 0. Now we have a simple linear equation. It's x to the first. We know how to solve that. We'll subtract 2. 3x equals negative 2. We'll divide by 3. Well, negative 2 divided by 3 cannot happen. Those numbers are both prime. So we'd leave our answer as negative 2/3. Well, it made sense to get one solution because the equation we actually got to solve for was linear. The problem was the original equation didn't start out to be linear. The original equation started out to be a square root. So the rule is when you take a symbol out of an equation, there's no guarantee the answer works. Therefore, you must do a check. So to check, we write the original equation. So here comes the original equation, everybody. There's the original. Wherever there is a letter x, I have to replace it, substitute in this number, negative 2/3. So I have the square root of 4. Up, there's an x. So I'm going to put negative 2/3, and then I leave the square. Plus 3. Up, there's an x. I put negative 2/3, and then I have, plus 2. That's the left side. On the right side, I have 2. Up, there's an x. There's your negative 2/3. Now, to really know if that's the solution, we got to make sure the left side and right side balance. We don't move numbers when we check. We've already discussed that. We work the left side, we work the right side, and we keep our fingers crossed that it balances. Okay, the right side's quick to work, so I'm going to work the right side. This is 2 times negative 2/3. Multiplying fractions is no problem. Top times top, bottom times bottom. 2 times negative 2 is negative 4. 1 times 3 is 3. So we're hoping the left side is going to come out to be negative 4/3. When we work the left side, we work inside the symbol first. And inside the symbol first, we got a square. So this is going to become 4 times negative 2/3 squared is negative 2/3 times negative 2/3. Again, multiplying fractions is no problem. Top times top, bottom times bottom. Negative 2 times negative 2 is 4. 3 times 3 is 9. Okay, so now we have that. I'm going to write what's everything's inside. Now inside, we have 2 multiplications. So inside the square root, 4 times 4/9. Top times top, 16. Bottom times bottom, 9. We have another multiplication. Top times top. 3 times -2 is -6. 3 times 1 is 3. Plus 2. We're still not done inside. We have to add and subtract. Well, now we need a common denominator. The common denominator, 9, 3, and 2, is 9, 3, and 1 is 9. Now look, we're adding and subtracting. We're not moving to solve an equation. So we need to make a common denominator here, which is 9. 9, 9, 9. 16 is going to stay because the denominator is 9. To make a 3 become a 9, we multiply by 3. So -6 times 3 is -18. To make a 2 become a 9, we multiply by 9. So 2 times 9 is 18. Well, what happens when you have 16/9 minus 18/9 plus 18/9? Well, these two fractions will add up to 0. So what we really have here is the square root of 16/9. What is the square root of 16/9? Well, it's the square root of 16, which is 4. It's the square root of 9, which is 3. So the left side comes out to be 4/3. But the right side came out to be -4/3. Are those equivalent expressions? No. Which shows you, even though you got an answer, that answer doesn't make the original equation balance. And if the answer does not make the equation balance, we have to throw this out in the garbage. That's called extraneous. So if the answer can't be -2/3, well, you don't have an answer. You just threw it out. And this is when you say the famous phrase, no solution. Or we use the symbol, the 0 with the slash. There is no number that we put on the left and right side that will ever make this equation balance. And that is it. We are done with Math 099. Have a great day.